Let's imagine you're sitting in the middle of your most important exam. You write down an answer, and then you realize it is completely wrong. Your heart sinks, but then you grab your friction pen, flip it around, rub the rubber tip over the ink, and just like that, it disappeared. It's clean, no mess, no smudge, like it was never there. But here's something strange. Leave the exact same pen, sitting in a hot car on a Bangkok afternoon, and when you come back, your entire little book is blank. Every single word gone. And if you put that same erased page into a freezer overnight, the writing come back. So what is actually going on inside this pen? Today, we're going to find out.
This story started back in 1975 at the Pilot Corporation in Japan. A researcher named
Norikazu Nakasuji
was sitting outside one autumn day, watching the leaf on the tree slowing change color from green to yellow to red. And he have a thought, what if ink could do exactly that? What if you could make ink that change color based on temperature, just like those leaves? That idea led to world's first thermochromic ink, which Pilot patented and called Metamorcolor. And in 2006, the fiction pen by Pilot launched in Europe, becoming a global sensation almost overnight.
So what makes friction ink so special? Inside the ink are millions of microscopic capsules, each smaller than the width of a human hair. Inside every capsule are three important ingredients working together. The first ingredient is a leukotype called crystal violet lactone, or CVL. This is the molecule responsible for producing color. The second ingredient is a developer, which is a weak acid. Its job is to react with the dye molecule. And the third ingredient is a fatty alcohol solvent. This solvent is extremely important because it can switch between solid and liquid depending on temperature.
Here is the key to understanding everything. At room temperature around 25 degrees Celsius, the fatty alcohol solvent inside those microcapsules is solid. Think of it like a tiny block of ice inside each capsule. And because solvent is solid, its whole glucose dye and developer physically lock in place right next to each other.
They are what chemists call molecular proximity, meaning they are close enough to actually touch and interact with the molecular level. They are starting the connection solvent-solid molecules together, and because they are together, the reaction can happen.
Now here's where the actual chemistry kicks in, because the glucose dye and the developer are sitting next to each other inside that solid solvent.
The developer, remember, it is a weak acid. Donate a tiny positive particle called a proton or H+ to the dye molecule.
Now, what's happened when you erase? You flip the pen around and rub the rubber tip firmly over the ink. That's rubbing creates friction, and friction creates heat.
Especially around 60 degrees Celsius, right at the surface of the paper. Now remember, the fatty alcohol solvent, that heat is enough to melt it. The solid solvent turns liquid, and the moment it becomes liquid, the crystal structure that was holding a glucose dye and developer together collapse.
They are no longer locked in place. They drift apart, like two magnets that were frozen together in an ice cube. And now the ice has melted and they were floating away from each other in water. Once they separate, the proton transfers stop completely and the inks turn completely colorless. It looks erased, but here's the truth. The ink is still physically on the paper. Every molecule is still there. It's just invisible.
And this is the part that proves the reaction is reversible. If you place the erased paper into a freezer, the low temperature causes the solvent to solidify again. As the solvent resolidifies, it pushes the dye and developer back close together. The proton transfer starts again. The ring structure reopens, conjugation returns, and the writing becomes visible once more. So the ink was never truly erased from the paper. The molecules were always there. The chemical reaction was simply turned off by heat and turned back on by cold.
So the big idea is this: the solvent controls the entire reaction, heat turns the color off, and cold turns it back on. You are not truly erasing the ink, you are simply hiding chemistry temporarily.
Thank you.